Hi guys, welcome back to the timeseries.net devlog. This is our episode 2. If you are just joining us, we have an episode 1 where I introduce the idea behind this project, building a native time series forecasting library in .NET, and we are starting with ARIMAX. So these are episode 2 and we are going to be starting by writing our first line of code. So let's lay up the foundation. So here's the foundation for the code. I have set up the solution using a standard clean architecture. Everything lives inside the SRC folder, in which we have two projects, the timeseries.core and the timeseries.test. The timeseries.core project is the project that we are going to call the core logic, and that will later be compiled into the nugget file that we are going to deploy as a library. The timeseries.test project is our xUnit test project. This will also help us in testing each functionality in the timeseries.core project. I also set up this project in such a way that I can implement other functionality once.
There are four basic folders I created for the layout of this project under the timeseries.core project. They are the math folder, models folder, utils folder, and the forecasting folder. The other folder are obviously folders that comes with creating a .NET project. The first folder we're talking about will be the math folder. This is where I'm going to do all the mathematical operations that we are going to need for our time series model, like the ACF and the PACF, and also the differencing. This is where I'm going to create the methods for them in the classes. The models folder is where we're going to create our model, like the ARIMA and the ARIMA X model. We talked about also extending to other time series model, but we're starting with the ARIMA X model. The forecasting is where we are going to do our forecasting, and the utils is like all the utilities that we are going to need for other classes during this project, and that is the layout for this project. In time series forecasting, we often start with data that shows a clear trend. This data can be either going upward or downward, like sales going up every month, or maybe you are in a weight loss plan and you want to show your daily weight loss. But many forecasting models like ARIMA and ARIMA X works best when the data is stationary. That means it doesn't drift over time. To make a series stationary, we use a technique called differencing. What's differencing? It simply means subtracting the previous value from the current one. So instead of tracking levels, we are tracking changes, like the monthly changes or the day-to-day changes in our earlier examples for the sales going up every month or the weight loss plan. Mathematically, this implies that y difference at t equal to y at t minus y at t minus lag. Hold on, wait a minute. What's lag? Lag tells us how far back in time we compare. That is, in lag 1 means we subtract from one time ago. That gives us y difference at t in lag 1 equal to y difference at t minus y difference at t minus 1. In lag 2, it will be y difference at t equal to y at t minus y at t minus 2. So in code, you can think of lag as a sliding window that says compare now to X step before. Let me give you an example. If you have a series, say these are the numbers in the series 10, 13, 17, 21. This is an upward trend. We want to get the difference. If you are getting into lag 1, it should simply be the first number, which is 10. We can't get the previous number, so we go to the second number, which is 13 minus 10, which is the first number. The first number is 10, which is 3. Then the next number is 17. What's the previous number for 17? It's 13. 17 minus 13 is 4. The next number is 21. What's the previous number for 21? Is 70, which is 21 minus 7, which is 4. Hence, our result is 3, 4, 4. This same series, if we are using it in lag 2, the first number 10, we can't get the previous number. So is out of it. Second number, 13. We can't get a previous two number because the previous number is 10. We don't have a previous number before 10. Hence, we'll go to the third number, which is 17. The previous two numbers is 10. Hence, 17 minus 10, which is 7. The next number is 21. The previous two number from 21 is 13. Hence, it will be 21 minus 13, 8. And our answer will be 7, comma 8. That is for lag 2. If you are doing for lag 3, we start with the same. 10 doesn't have the previous three steps, so it's out of it. Same as 13, no previous three step numbers for 13. The next number 17, there is no previous three steps number. The next number is what? 21. 21 has the previous three step now, which is 21 minus 10, which is 11. Our number for in lag 3 will be only a series containing one number, 11. Differencing with the right lags help remove strength or seasonality, letting us focus on the core dynamic of change like volatility, shocks, or pattern cycle. Having explained the concept of differencing, we'll go ahead and implement it on our code base. So this is what I did in my code base. I created a class called differencing.cs on my math under my math folder. This class has two main methods, which is the difference method and the inverse difference method. I'm going to explain what each method does. The difference method is the method that does the difference, which we explained earlier. It takes the data you're trying to, the series you're trying to difference, and takes collect the lag. So it assumes that the lag is one, but you can impute any other lag if you don't want to use lag one. And also we do what we call the cumulative differencing. Yeah. So this is the method. You can clone the project and go through the method again. So we also have the inverse differencing, which takes the difference data, the original data, and gives you the result back. So guys, you can clone this method and you can clone this project from the repo and go through this method and see what each method does. Here we also implemented an extension called the difference extension where we do multi-order differencing, which means we can do differencing for the first order, second order differencing. This basically means after we do the first order differencing, the differencing on the first order, we can do differencing for a second order, which means we are going to do a differencing on the existing differencing. That is what this essentially means. And also, I created a test case scenario for this differencing. You can see the test case scenario under the time series.test, and you see the differencing test.cs, where we create test case scenario. To test our case, I just go to my terminal, then I run the command .NET tests. Boom. All my tests pass. You can clone the project, write the test cases, run the test cases, and you can ask any question uh, where it seems ambiguous under the comment section. I will try as much as possible to attend to questions under the comment section. Let's engage there. So that's it. That's episode 2, guys. What we have here is a fully working differencing engine with test and validation. In next episode, I'll be working on the autocorrelation, the ACF, and the PACF, the partial autocorrelation, which are also key in estimating ARIMA parameters. Follow this journey on GitHub, start the repo, follow me on LinkedIn for update, and let's keep building the future of forecasting in .NET together. Thank you. I'm Joshua Chiku.